Hello everyone, I'm Yancheng, and today my topic is Improving Jump Point Search by Daniel Harbour and Algan Grasstein. So there are 6 parts of today's topic. First, I want to discuss prior and related works. So about the A-star algorithm, this is very familiar to us, and it is also a basic idea that of today's algorithm. And there are another 3 kinds of related works. First one, the transit and the hierarchics. It is a method that can pre-compute the nodes in the map and lead to the shortest path. And another one, the swamps hierarchics. It is a pre-compute method that can provide the areas in the map that you don't need to search. And the final one is called sub-goal graph method. So this is a pre-compute method that provides us with the visibility graph and also pruning rules. So what is a jump point search? This is an algorithm that based on the A-star algorithm with 2 rules, pruning rules and jumping rules. We can see in the right hand that in the example, the jump point search can scan the map very quickly, and it does not need to use too much memories to store the nodes. And what is the pruning rules? So these rules give us the 2 cases that we can prune the nodes. In the first case, the red one, if you can find the shorter path, then you can prune these nodes. For example, like you can find the 4-1 instead of 4x1, then 1 can be pruned. And in the next case, if there is a path that has a diagonal move earlier, then we can also delete this path, this node. For example, you can find the 4 to 3 instead of 4x3, then 3 will be pruned. So another rule is called jumping rules. This rule gives us an idea that you can jump through one direction until you find the dead end that will hit the obstacles. So when it hit the obstacles, the whole path will be abandoned, and the planner will find another restart point and keep the searching. So another part of today's paper is the improvements that can be applied to the JPS. So the first improvement is called block-based symmetry breaking. So this gives us the idea that can detect the 3 kinds of nodes: the dead ends, the false neighbors, and also the target nodes. So the important things I want to mention is the false neighbors. So these can compute the information of 3 lines and give a function to compute whether there is a false neighbors in these lines. For example, you can find as the output, there is a 1 here, so we can find, okay, so there is a false neighbor. You can turn the direction and keep the searching. You don't need to store these as the dead ends because there is a way in another direction. So this is very important. And the other improvement is called pre-processing. So this is the idea that you can pre-compute offline before the running. So like the first case, you can start the pre-compute with the start nodes in 8 directions and divide these nodes into straight jump points and the diagonal jump points. And in the other part, in another case, you can pre-compute the target nodes with 2 lines. So if your planner hit these 2 lines, get these 2 lines, then they will get the information. Okay, there is a target node here. I can change the direction and get to there. So the third improvement is called the improved pruning rules. So this is the idea that if you find the dead end near the obstacles, You don't need to abandon the whole past. You can uh, you can store the successors in the past before the computing, and if you find the dead ends, you can restart from the successors. For example, as the yellow one, um, you can jump into the node 7, and restart searching. So in this case, you will avoid some pruning of very important points like node 5 or node 7. So this is the main idea here. So the part 4 is about the comparison. First, let's compare it with the formal version of JPS. There are 3 plots here related to 3 kinds of computer games. So the left side of the plot gives us the improvement of memory use, and the right side gives us the improvement of time cost. We can see that the improvement did a really good job, and especially in the preprocessing and the improve of pruning rules. And the next part is the comparison with sub-goal algorithm. This is also a very famous algorithm, and we can see that the JPS also did a good job, and it is also very competitive. So in the conclusion, I want to mention the advantages and disadvantages. So this can give us less scanning time and less memory use, and can avoid the wrong pruning. Also, it can provide us with the combination of online and offline computation. So this can let the work environment very flexible. You can do it online or offline. But the disadvantages here is that it will work hard in some special case, like this map with 3 obstacles, waste a lot of time in the left side. And also you need to recompute when the map changed, especially in the real-time computing. So about the further work, we can apply a value function to the pruning rules that can discuss that whether these nodes should be pruned, and also we can provide the combination with the very famous speed up techniques. And the final idea is to give us a database that can compute online, and so we can cooperate with others, especially in the dynamic environment. So here are today's topic, and these are the references. Thank you for your watching.